all of you. Shenzhen. It's very exciting for me to be here. I've been here a couple times before, and I've had a wonderful time seeing how Shenzhen makes things for the world, and it's been wonderful to see that over the years. I'm very excited this time because I get a chance to see what you make for yourselves, and that's what I'm looking forward to seeing at Maker Faire. I didn't get the clicker though. I may know how to use a microphone, but I don't know how to use a clicker. So how do we go to the next slide? Thank you. I wear two hats actually. I work for Arduino. I'm one of the co-founders of Arduino. But I also teach at the, thank you very much, at the Interactive Telecommunications Program at New York University. We call it ITP. And I've been there for 15 years or so, and it's really my home. And as we mentioned, I'm also, oops, let's see if I can make this one work. There we go. I'm also part of this group, backing up one. Yeah, there we go. No. There we go. Arduino. These are my co-founders of Arduino, Massimo Banzi, David Marquez, David Mellis, and Gianluca Martino. And the two sides of the world kind of come together. We collectively made Arduino happen, and it's a tool for beginners to learn how to make electronic devices. How many people in the room have used an Arduino or an Arduino derivative, just so I know? All right, so I don't have to explain too much. Good. I should warn you that I am not Massimo, and so you're not going to get any sneak previews or any bold new directions about the company today. I leave that to him. But today, I want to talk about how Arduino relates to ITP and how they both relate to making things. Now, ITP is a 2-year graduate program, and we teach people from all different disciplines how to make interactive technologies. We get people from many, many fields. We get them from the arts and the sciences, but there's more than just those two dynamics. We get people from sociology, from politics, from marketing, from economics, from all these different disciplines. And part of the challenge with that is getting them to talk to each other because they don't know each other's background. They don't know how to communicate with each other. And so one of the biggest challenges is getting them to explain themselves to each other. Much like you have to do at a cocktail party. And in fact, I think one of the most important parts of our job is to run a good cocktail party. When we get people, as Chris was saying, when we give ideas away, when we get people to be intellectually promiscuous, when we get them to just share their ideas freely, we get some really great things out of ITP, and we try to make it a very social space like this as a result. As I say, sometimes it's a little difficult to explain yourself to other people and you think you're talking to yourself. And one of the things that happens at ITP a lot is we don't use technology just to make tools, we use it to express ourselves. This is Kate Hartman, who's now teaching at OCAD University, and she's made a number of projects that try to take the ideas that we use as metaphors in talking about technology and make them into real and very humorous. I'm not sure if they're art or technology or both, and I don't care, I love them. It takes a lot of patience and it takes a lot of forgiveness to learn each other's languages and styles and backgrounds, though, and that's really, I think, the hard part of our job, but it's also the most enjoyable part. I teach physical computing at ITP, and for those of you who don't know the term, physical computing means teaching people to think about building interactive systems by starting with the person and what the person does. What are they physically going to do? We often start at Maker Faire and Maker events thinking about the technology, but really it's what the person does, what they're physically capable of, that is what makes things interesting. So I tell students to think about that physical action first, and I teach them that if they start there, then they can figure out the right sensors or the right tools. They often get really excited about technology, and the challenge is actually to turn them around and get them excited about each other again. And that's what I would encourage you to do too. Get excited about each other and what you can make for each other. Sometimes you see students make really wonderful expressive projects. This, for example, is a student named Matthew Richard, and he's a painter. And he's really interested and inspired by other painters like Mark Rothko and the color field painters, and he wanted to make color paintings come alive. So he learned mechanics, he learned electronics, he learned lighting, and he made this really lovely piece of art. And you know, we look at it and go, oh, that's some really amazing technology. How is he moving the motors? What's the gears behind it? It's art. We don't care. All we care is that it's beautiful. And that's a really important thing. You have to care beyond just what the technology is. Sometimes people build very personal things at ITP. This is Justin Lang, one of our current students, up in the corner there, and that's his father. And his father is a guitarist, and his father lost motion in his left hand, so he could no longer play the guitar. So Justin used the skills he developed to build a guitar that his father could play again. So sometimes we use technology to make our own lives better and our own families' lives better, and that's important. Other times we do it to make other people's lives better. And this group of students, now faculty, John Schimmel, Marilyn Ingram, Letta Cross, and Tristan Parrish, working under the tutelage of Marianne Petit, who's here in the audience, who runs the IMA program at NYU Shanghai now. They developed this tool for a student at a high school in New York, a high school for students with various different abilities. This kid was confined to a wheelchair, but he was so physically expressive with his chair, and he really wanted to make music. He really wanted to be a DJ. So what the students did is they built him a DJ table with his wheels. Because he could move his wheels so much more powerfully and so much more eloquently than anything else, they said, well, let's use that. That's an ability. And so that came out of it as a result. Sometimes students make tools to explore the rest of the world. These two were a mechanical engineer and a veterinary technician who was a performance artist by night, and they made a laser rangefinder because they were working with a primatologist who wanted to study how monkeys grow, but he didn't want to capture the monkeys, so they made a tool that could paint the monkeys with an exact target so they could measure them. Now, this was from a class that I was teaching with the primatologist, and the idea of this had been done before, but it's the first time that somebody had tried to do it just with off-the-shelf parts, as Chris was mentioning earlier. So there are all these different reasons why we might engage with technology. Sometimes we'll do it to instruct. This group of students was working on museum exhibits about how vision works, and they couldn't really explain to people just in words because vision is something we experience. So they made a project so that you could see how we see. You take those plugs down there and you plug them in, and you can see how different people see, or how we see through our rods and our cones and so forth. All of these things are important when we start to think about technology. They're really the driving factors. And if there's one thing that all of these students, are interested in, let me back up there, it's that they're interested in applying technology, but they're not interested in being engineers. That's where Arduino comes into the picture. Now, I have been teaching for years with various tools, and if you've done engineering, you've done software like this. There's a lot to it, and it's very difficult to learn. And all of that stuff was written with the assumption that you already knew something. That wasn't the case, so I had to write my own tutorials and so forth, and that's where Massimo and the Avrea team started using my materials, and then they started developing Avrea. Now, they started developing Arduino. Now, Arduino grew here at the Interactive Design Institute in Avrea. I wasn't there at the beginning, but we have a common history between ITP and Avrea through many different sources. This is sort of the prehistory of Arduino. And so it wasn't a surprise that we might end up eventually working together in 2005. And in the end, it really ended up being a combination of things, not just hardware, but also hardware and software, and the community, as Chris was mentioning. Arduino would not exist without that community. In fact, that's really the heart of it. And the other part to me is that hands-on learning. We can make simulators, we can make virtual tools, but it's not until you get your hands on it that you really figure out how this stuff works, and we really encourage users to do that. And for me, that wasn't anything new. My students were already doing that, so that's just natural to me. Maker Faire has also been a big part of my life over the years. My first time I went was in 2007, and I feel like Arduino and Maker Faire have kind of grown up together in a way. Can't imagine that either one of them was going to end up here, but it's kind of cool that they did. The first time I came, I brought a couple of crazy students who were working on plants. I think one of them's in the audience here too. I want to just point out that in this group you've got a cognitive psychologist and sometimes programmer, you've got a botanist, you've got a graphic designer and sometimes political activist, you've got an artist there. And so when I say lots of different disciplines in one group, I really mean it. Now what did those 4 people end up doing? Well, of course they went to a bar. But what they really built was a system where your plants could call you and tell you that they needed water or that they needed light. They built a system called Botanicals. And that's what we brought as one of the projects to Maker Faire our first time back in 2007. And it was really a wonderful experience. What we discovered at Maker Faire was it felt like we found all of our long-lost relatives. All these people who it didn't matter what their background was, they just wanted to make stuff, and that was great. So nowadays you hear a lot of talk about programming literacy or technology literacy. And if you look it up on Google, you'll get about 15 million hits. You'll also find some wonderful programs around it. Code for America has gotten a lot of press lately. Girls Who Code, I think, is awesome. Black Girls Code is another really great one. You're sensing a theme there. It's something I care about a lot. But what does literacy mean in this context? When we talk about literacy, it's much more general than to talk about technological tools. Technological tools are professional things. They require training. They're not like everyday language, right? But we use language in all kinds of ways. Well, we can use language informatively. We can say, that's a skull. We can use it poetically. We can express ourselves in quoting Shakespeare when we talk about the skull. We can use it playfully. We can make up jokes and play with what language can do for us. In fact, a little side story about this. When I first started to come over for this trip, I had a problem. I couldn't fill out that part of my visa application, so I spoke to my Chinese colleagues and students, and I said, what do I put in here? And a long-spirited debate started on Facebook, and they finally came up with, well, Igoe. How do we say Igoe? Well, what they came up with was this. So I have now earned a new nickname, Love Puppy. You take what you can get, but that's the fun of language, okay? So when we use language, we're forgiving. We don't ever use it properly. We leave things out and we try and figure out what things are, but we get the message across, and that's really important. This is something that isn't necessarily true with technological language. It's not very forgiving, and it's not very creative yet. But that's the thing I think we really need to change and work on next. When you go to online forums and you ask for help, you ask for what to do, this is often what you're told. But that's changing, and that's something that I think is really important to change. You don't always want to change it. Engineering should be strict sometimes, because when engineering doesn't work well, you get this, right? When engineering doesn't work, people die. But not always. There are some times when we can be more forgiving about it. We can tell people instead, why don't you tell me what it is you're trying to do? Why don't you tell me your background, and we'll figure out what we can do together. That's what I'm trying to encourage when we start to think about programming literacy. You're seeing this a lot on the web. All the web tools like Node.js and Flask and so forth, they made it very, very easy to set up a web server. We're not there yet in hardware. Arduino is good, but we could be better. There's a lot more things that could be out there. So if I were to say, what should whoever wants to make the next Arduino, the Arduino killer do, they should be empathetic to their customers. They should try to solve all of those problems that don't get solved all the time, the ones we overlook, okay? On the web, you see them with things like Twyla, that's by Temu, where they've taken and broken down web tools into simple components. They don't actually try and keep the structure of programming anymore. Same thing with Node-RED. They just say, well, now I'm going to make a request. Boom, done. I don't have to worry about this stuff under the hood. We have tried to do that, use things like Scratch for Arduino, but they're not perfect. This still keeps the complexity of programming. It just takes away some of the punctuation. It's not there yet. We got a long way to go. Even in Arduino, this is the most common error that comes up all the time. Anybody seen this one? Yeah, what does that mean? It means the software can't talk to the hardware. And it gets looked up an awful lot in our forums. Why haven't we solved that? Well, it's actually a dozen different problems, so we haven't bothered to tackle it. It's a hard problem, and after you've done it a while, you learn to look past it. But that's the problem. You shouldn't look past it. You should remember that beginners need to solve it. So this is, to my mind, the future of Arduino is solving that one. So we're always going to be moving forward. We're always going to be trying to get things a little bit better. I'm going to just leave with the last couple of words. I say, number one, be forgiving of your beginners. Always be forgiving of your beginners. And maybe what you'll find is, after a while, they're no longer beginners. When we think about code literacy, here's the nut graph of this whole thing. We don't need to make everyone better programmers. We need to make programming better for everyone. And that is where I want to leave you today. Thank you very much, and have a great day.
Thank you, Tom.